Hope you all be fine. Now yesterday we have completed first chapter for statistics, and I would like to appreciate the students. Within a short time you have written all the notes and have submitted to me, so that is a very good thing to know. And others, those who cannot complete for any reasons, no problem friends, complete it today and send it me till as per your possible till midnight or everything, but till tomorrow you should complete. Okay, tomorrow you should cope up with the sums of this chapter. So appreciating the students who have completed that work, and that work is very proper and very good. Okay friends, yes, now today onwards we are going to start the second chapter of statistics, that is presentation of data. Friends, in first chapter we have learned about the collection of the data, how to collect the data, what are the types of data, what are their methods, what are the advantages, what are the limitations. Yes. Now, in order to collect the data, it is not only a simple thing to collect the data. Just you collect the data and keep it with yourself will not be useful to any way. So what is the next step to collect the data? After the collection of the data, you have to present the data properly. Suppose you are collecting the information from a large area or any type of area, maybe small area or a limited area, your data will not look good as you have collected the data, but you have not analyzed it, you have not kept in a proper form which can be understood by you. So what is the next step? Next step is to present your data, and for that we are learning this chapter. So friends, on page number 15, a topic is given about classification. What is given? Classification. Now friends, classification is a familiar word with each of everyone, and what we can say about classification? Classification means to arrange. Suppose when you are admitted to the school, your level is lower KG, then higher KG, then first, second, third, and so on. You are going till 12th. So that is also a type of classification. How? You are a child and you are admitted to the school at the age of 3 or maybe 3.5 or 4. So what is your level? Your level is now junior KG. In the same way, you are of 16 to 17 years. Now what is your level? Your level is +1 and +2, means 11th and 12th. So you will be classified in such a way. Or if your age is 8 or 9 years, then you will be classified in that type of class. So this is again, classification means arrangement. School is arranging different types of students in various classes, and telling the teachers also to teach them in such a way so that their education will be from lower level to. In the same way, when we are collecting the data, that is can be from primary data, or that is can be from secondary data. Okay, secondary data does not require that much of classification, but the primary data requires so much classification, and after that classification only we can analyze, we can draw some results from the data. So classification is just arrangement of the data. Now what they are writing, some of the things they are writing which is to be seen. In the previous chapter we have seen that the statistical information consists two types of data. Yes, we know two types of data: quantitative data, that is with numbers, and qualitative data, that is with attributes. Attribute means different subtypes. Quantitative data are based on quantitative variable, whereas qualitative data are based on qualitative variable, that we know. Quantitative data is of two types: discrete and continuous. What type? Discrete variable, continuous variable. All these things have been learned in 10th standard itself. This is just a revision. If a variable can assume definite or countable values within the specified range, it is called a discrete variable. Now you may underline this. What they are writing? If a variable can assume definite or countable values within the specified range, then that data is a discrete data. Example we don't need. If a variable, and after in the next line is written, if a variable can assume any value within the specified range, it is known as a continuous variable. A fixed, then discrete, and a specified range, then continuous. Okay, again example is not required. In practice, if we have to count something for obtaining the value of variable, then it is called a discrete variable. Okay. Again an example is given that is not required. If you have to measure the observation for obtaining the value of variable, or if the value of variable is expressed along with the measuring unit, it is called a continuous variable. Again you may underline it. This is not required, but just you need to know what is that continuous variable. Okay, then again something is given that is not required. Now the last sentence, the data based on discrete variable are called discrete data, and based on continuous variable are called continuous data. That is again giving an information. Okay. Then next paragraph, the data obtained at the end of sample inquiry or population inquiry are called raw data or ungrouped data. Okay, this is again very important thing. What they are telling, this thing is to be understood properly. See friends, again I am reading. The data obtained at the end of sample inquiry or population inquiry are called raw data or ungrouped data. This is very but obvious thing, but now itself I have said that when you are collecting the data, that is primary data or secondary data, that is you are collecting from all the units, that is population, or you are collecting from the specified units, that is sample. Now that data will not be classified, will not be arranged, will not be calculated, or will not be analyzed. You need to do that analysis or calculation with it. Now that data is known as ungrouped data or raw data. Okay friends? Yes. These data are in haphazard form, so statistical analysis becomes difficult. Haphazard means in any way. Okay. Hence it is necessary to arrange the data in a systematic and short form. Now see, a important definition is given. A process of arranging ungrouped data or data in proper form is called classification of data, and data thus obtained is called classified data. Please underline that thing. Again I will read once more. The third line, mid-third line is given. A process of arranging ungrouped or raw data into proper form is called classification of data, and data thus obtained is called a classified data. Okay, example is not required again. Now thus the next paragraph, thus the method of representing raw data into systematic and short form is known as classification. Again they are giving what is classification. In statistical study, the main reason to classify the data are as follows. This is not for exam, but this is for understanding why we need to classify the data, what is actually the need. Okay? Yes. To represent large data into simple, short and attractive manner. I may give this example considering the computer study. Now till 10th standard, you have learned different uses of computer and different things in the computer. Yes? Okay. Now, I may say it as an example that if you want to prepare an Excel file, then Excel files has rows and columns. Yes? Okay, now Excel files has rows and columns, that is also okay. Now, if the data is very long, it cannot be fit into screen also, sometimes we need to scroll down. So it is not practically possible to compare the data at every time. Why? Because some data is given in upside, some data we have to compare with the scrolling down. Full screen also we are not getting the whole thing, we have to scroll up and down. Now the same thing we have learned through the charts or diagrams, and you have practically drawn also in standard 10th and 9th. Now what we were doing, we were classifying the data and we are representing it through diagrams or any graphs. Now what that actually says that this data, when we are showing pictorially, means through the pictures or graphs, then analysis will become very easy. Why it will become easy? Because just we can see and we can compare. But instead that scrolling up and scrolling down every time, that will take time, and sometimes wrong conclusions can be taken. So friends, it was advisable to show it through graph. And the people who are uneducated, suppose the people are uneducated and we need to give explanation of some data, then if we are writing and giving, then they will not understand because they don't know to read and write. Now how that people will understand our data? If we are presenting it through graphs, then they can understand. This is the big line, so this is the highest, this is the smallest line, so this is the lowest. So the people can understand us and understand that what we are telling to say them. So again, this is required in the way, here also they are writing, when the data is very large, it can be presented in very simple, short and attractive manner. For easy comparison between the various characteristics of the data, again number 2 for the what we are writing, for easy comparison between various characteristics. Characteristics can be very different. As I have given example in the previous chapter, that we are taking people from XYZ area, from any area. Now again we need to sub-classify it, how many are male and how many are female. Now again small subtypes classification are married and unmarried people, from males married and unmarried, from females married and unmarried. So what is the thing, friends? You are diversifying the data in very deep way. Now we can understand the data, but illiterate people cannot understand. So through arranging it, we can compare it to save time, money and labor. To obtain information easily regarding various characteristics of data under study. So all these things. Okay. Now friends, on page number 16, we have been given types of classification. How many types of classifications are there? Okay. There are two types of classifications: classification of quantitative data and classification of qualitative data. Okay. Two types of classification we will learn: quantitative data and qualitative data. Okay. Again, an example is given, that is not required. Okay. Now directly I am going classification of quantitative data. There are two types of quantitative variable: discrete and continuous. See, the data can be classified types of classification in that we can give two main types, that is classification of quantitative data and classification of qualitative data. Okay friends, now first we are looking classification of quantitative data. Again, two subtypes: discrete variable continuous variable. Okay, so discrete and continuous are two subtypes. Classification of discrete variable is called discrete frequency distribution, and classification of continuous variable is continuous frequency distribution. Frequency means how much times it is repeated. Okay, now we are going for discrete frequency distribution. Okay, in that we need to underline, so please ready with your pencils. A numeric value showing the repetition of the value of an observation is called frequency of that observation. Underline please, we will require it for one sentence. What is frequency? Frequency means showing repetition of the data. Again I am reading, a numeric value showing the repetition of value of observation is called a frequency, and it is denoted by a small letter f. Okay, then next, a table showing various possible values of discrete variable with their respective frequency is called discrete frequency. With frequency is called discrete frequency distribution. Okay friends, yes, again examples are given, they are not required. Okay, now one important formula is given after in page number 17. After the example, the difference between maximum and minimum value of variable is called raw data, and of raw data is called range. What they are telling, the difference between maximum and minimum value of a variable of raw data is called a range. It is denoted by R, and range R is equals to maximum value minus minimum value. Please underline that thing. Okay. So you need to write in your book also how you will start this chapter. You will write the name of the chapter, then you will write types of classification. Okay, which are the things required for this? I will say now itself. First you will write the name of the chapter, then you will write types of classification, and what I have written: types of classification, classification of quantitative data, and classification of qualitative data. Then here you will write discrete variable, here you will write continuous variable. Okay friends, no, so these things has to be written. Then after this thing, what you need to write? Range. Its definition is not required, just to underline that definition. Difference between maximum and minimum value of raw data is called a range, and range R is equals to maximum value minus minimum. Okay? Yes. Okay, when one note is given below it, when the range of discrete variable is too large, then discrete frequency distribution of data is not advisable. In such case, inclusive continuous frequency distribution is appropriate. Okay, these I will give explanation when we are doing the sums. Today we are only introducing the chapter. Tomorrow we are solving the sums. Okay, on now page number 18. Okay, everyone, on page number 18, continuous frequency distribution. So I am reading it. A continuous frequency distribution is carried out when the value of raw data is continuous or range of data is very large. See, if the range or if the difference is too large, you cannot present it through discrete variable. Why? Because so much of things will be written vertically. Now instead, what we should do to cut short the data, we are using continuous data. All of you may be knowing, but you may be forgotten. When we are solving the sums tomorrow, you will understand it properly. Okay, but now for instance, what you need to keep in your mind, that when the range is very big, we are to use the continuous data. For these, first of all, the number of classes K or class length C is to be decided for raw data. Please underline that thing. What they are telling for continuous data, number of classes. Number of classes is denoted by capital letter K, or the class length. Class length is denoted by C is decided. Generally, depending on the raw data, the number of classes 6 to 15 is decided for the number of classes. Please underline that. According to the data given, friends, how much minimum or how much maximum classes you can make a minimum 6 and maximum you can make 15 classes. There is no fixed rule, but this is an advisable rule. Okay? Yes. It should be noted that this is an accepted as universal trend. It may not be true for every study. For every sum it is not okay, but for most of types of sums, minimum 6 and maximum 15 classes are advisable. Not more than 15, not less than 6. Under special circumstances, the number of classes may be less than 6 or more than 15 also. Okay, that is a different thing, but in general practice, 6 to 15. Yes. After deciding the number of classes, the class length C is to be determined for each class. Okay, for this purpose, range R of the data is divided with the number of classes K. Practically, the value of number of classes K and the value of class length are decided in such a way that they are positive integers and their product value is at least the value of the range. What they are telling, see again I am reading how to decide the continuous value, decide the class, deciding the number of classes. The class length C is determined for each class. For this purpose, range R of raw data is divided by number of classes. You don't need to write, I am just explaining. Range R is divided by number of class length number of classes K, so we will get estimated class length. But what they are telling, this should not be in decimal values. We should get a positive integer. We should get a integer value without points, and if it is not possible, then we have to somewhat round off. Okay? Yes. In notation, C multiply K greater than equals to R. C. Both can be multiplied and greater than equals to R. How it is possible when we are doing the sums, we will see it. If the class length for the different classes are equal, then it is called continuous frequency distribution with equal class length. Underline this thing, friends. What they are telling, I am reading it again. After this formula they are writing C into K greater than equals to R. After that you need to underline. If the class length for different classes are equal, then it is called continuous frequency with equal class length. Okay? Yes. Whenever the range of data is too large, then depending on the given information, the class length may be different also. It is not a rule that you need to keep the class lengths equal, but sometimes they may be different also. Okay. It is called a frequency distribution with unequal class length. Down there, that is not required. After deciding the class length, class limits are decided for each class. On the basis of class limits, continuous frequency distribution is categorized in two ways. Please underline that thing. Continuous distribution is categorized in which two ways? Exclusive and inclusive. Suppose 0 to 10, 10 to 20, 20 to 30, or 0 to 9, 10 to 19, and 20 to 29. These types of classes, two different types of classes are there. Then this is called a exclusive classes and these called inclusive classes. You may be knowing this thing, but just I am repeating for everyone. For the classes, the upper limit and the next lower limit are same, then they are exclusive classes, and the upper limit and the lower limit of next class is not same, then there are inclusive classes. Underline that thing, exclusive frequency distribution and called exclusive class. In exclusive class, sorry I have skipped, exclusive frequency distribution and inclusive frequency distribution. Now after that I am telling you, if the upper limit of any class and the lower limit of next class succeeding class are same, what I said is the same thing, is called exclusive classes, and when it is not same, they are inclusive classes. Okay? Okay, now in the next page, page number 19, next paragraph, usually exclusive continuous frequency distribution is carried out for continuous raw data, and inclusive continuous frequency distribution is carried out for raw data having large value of range. Whenever it is used, underline this. For converting inclusive continuous frequency distribution into exclusive continuous frequency distribution, each class limit of inclusive frequency distribution is replaced by class boundary points. The lower boundary point and upper boundary point of class are calculated by the following formula. Okay, again you may write this thing. See, what are the things that are to be written in the notebook? First you will write the name of chapter, then you will write this thing, then you will write the formula for range. Now after that, write these things also. Class boundary points. Okay, now in that, number 1, lower boundary point. In short, we will say it as LBP. Lower boundary point is equals to lower limit of that class plus upper limit of previous class. Plus upper limit of previous class divided by 2. Then upper boundary point, that is UBP, upper limit of that class plus lower limit of next class. Succeeding is written, but next class divided by 2. One more formula is given. Upper boundary point is equals to midway, boundary point plus class length. Okay, so write these formulas: lower boundary point, upper boundary point, two formulas. And how you will remember, the hint is that when you are finding lower boundary point, so start with the lower limit of that class itself plus the upper limit of previous, because we have taken lower, so upper should be previous, divide by 2. When we are need to find the upper boundary point, use upper limit and lower limit of next class, because previous class is used. So how to remember it very easily? It is very easy. Lower boundary point will start with the lower limit of that class, upper boundary point will start with the upper limit of that class. But what we need lower, so go previous, upper of previous, and we are finding upper, so lower of next. In that way also remember. And one more formula: upper boundary point is equals to lower boundary point plus class length. Yes. Then again one more formula: class length is equals to upper boundary point minus lower boundary point, UBB minus LBB. In short, we can write. Then an average of class limit is called midpoint or mid value of that class. So again, mid value, lower limit plus upper limit by 2, lower limit plus upper limit divided by 2. Okay, so write these formulas, and two more formulas also need to be written, that I am writing in upside. Now they are telling on page number 19, when the mid value of the class and class lengths are known, then class limits can be obtained. When mid values and class lengths are known, then following formulas are used to find the lower limit and upper limit. Okay. Upper limit is equals to mid value plus 1 by 2 class length, and lower limit is equals to same mid value minus 1 upon 2 class length. Means there are sums in which mid values and class lengths are given, and what we need to find lower and upper limit. So upper limit can be found by adding the class length with mid value, and by subtracting for that we can find the lower limit. So you may write these formulas also. So these are all the basic knowing itself, nothing new. And again in the theory part, page number 24, what they are writing: cumulative frequency distribution. You may all know this thing also, but just we need to underline the theory part so that we can start the sums tomorrow. And these things are to be okay. Cumulative frequency distribution. Sum of frequency up to the value of an observation or a class is called a cumulative frequency CF, and its distribution is called cumulative frequency distribution. Underline that thing, what is cumulative frequency distribution. 1 marks question is there, no need to write but only underline. Okay, what they are writing again, we will say sum of frequency up to the value of observation. We are adding the frequency one by one, and that frequency is known as cumulative frequency. Okay, now there are two types: less than type and more than type cumulative frequency distribution. Okay, so the sum of frequency up to the specified value of observation or specified upper boundary point of class is called less than type cumulative frequency distribution, and that distribution is known as less than type cumulative frequency distribution. Means the sum of frequency of the specified value of upper boundary points. You can remember in such a way, less than type will have upper boundary point and more than type will have lower boundary point. Okay, then the sum of frequency of the specified paragraphs are to be underlined. First is what is cumulative frequency distribution, second is what is less than type, third is what is more than type. Last paragraph, when the cumulative frequency distribution is obtained by considering the value of discrete variable, it is called discrete cumulative distribution, and with continuous it is known as continuous frequency distribution. So both these things are not required, but on page number 24, 3 of the paragraphs are to be underlined, 3 questions can be done from them. Okay. Now, page number 29, the different points are for continuous frequency distribution, that is for solving the sum, that we will see tomorrow. That's all for today. The things which I have said is to be written in your notebook, and yesterday's homework also should be completed as soon as possible. Okay.